We're back with another Ask the Experts, and I'm talking with Harsha Chintalapani, co-founder and CTO of Collate and co-creator of OpenMetadata. Welcome back, Harsha.
Thanks, Shawn. Good to be back.
So in a recent episode, we talked about your background as a Kafka committer, PMC member, how Kafka works, and the massive data scale you were dealing with at Hortonworks and Uber. And that all led to a discussion into kind of push versus pull architecture decision for metadata ingestion, and why, with all your experience, you chose to not use Kafka for open metadata.
Yeah, that sounds good. I'm going to kind of continue with the last episode where we kind of showed the diagrams and everything, which will help us articulate better. So with that, I'm going to share my screen.
Okay.
So just to kind of land it here, right? So what is Kafka used? Kafka used for in many organizations a way to distribute the load of your logs, your analytics, your events. Could be any events, right? The context of why Kafka is important, why Kafka can scale is you have the same data. Let's say you have application logs that are pushing from your online e-commerce platform into Kafka. Traditionally, before Kafka, people probably used to ship it to S. And again, there is a latencies and S3 rating and everything else. The idea here is if you're shipping for one use case, that's good. Any mechanism is good enough. But if you're shipping for many use cases, maybe there's a platform team who wants to understand how many clicks are happening on a particular product. That's one use case. Another team, probably an ML engineering team, wants to understand what's the user behavior coming into e-commerce platform, how
Yeah.
they are leading to one page to another page. Another team wants to develop, hey, what is the related items where the users are clicking? The related items could be, I probably searching for camera, I land on camera, maybe I go to a camera strap or something like that. So all of these are different use cases, but they probably land on the same data. So how do you enable one producer pushing the data and many consumers reading the data? So that's his ideal use case for Kafka. Latencies are important. Kafka enables you to kind of push millions or if not trillions of events and scale out independently on the consumer side to many of these use cases. So
Yeah.
you're not penalized to read the same data. And one consumer reading at their own pace doesn't affect another consumer either. So my use case probably I want to look at every hour, another use case probably every second, every millisecond. So
Yeah.
that's where the ideal scenario comes in for Kafka. Now, taking into account of what is a metadata looks like. So you have snowflakes, you have Tableau, you have dashboards and everything else.
Right.
In any of these data sources, let's take an example of Snowflake, Databricks. You have data warehouses. So whenever you create a table, whenever you alter the table, how does that particular event translate into a metadata event that can be captured and pushed into open metadata? So for that to happen, Snowflake needs to notify an external system that Harsha came in and created a table. Shawn came in and altered a table. So all of these things as a notifications or events, some Snowflake has to provide an interface to listen to. It needs to enable a push mechanism so that a Kafka can capture that as an event. So,
Right.
so far in the industry, that hasn't happened. Outside of one or two, like Hive and Glue does that. Again, Glue does that through its own event hub in AWS, not through Kafka.
Mm.
So in that world, how do you actually enable Kafka-like system? So that's what we are trying to showcase here in the first image.
Mm.
So there should be a Kafka producer that is polling Snowflake for what happened in last 24 hours and take that events and push to Kafka. So your Kafka producer is running, polling constantly after Snowflake, push into Kafka. And the other side is a Kafka consumer has to be that can pull
Yeah.
Kafka events that are there and push to metadata store. So this is a complex
Yeah.
architecture that you end up building. And the question always has to be from an architecture point of view, you want to minimize the components that you want. You don't want to create services for the sake of services because the industry or someone said that, hey, Kafka is for your real-time events.
Yeah.
So nothing real-time happening here. You still polling the Snowflake. You're still pushing to Kafka. You're still pulling from Kafka consumers and pushing to your metadata store. So
And
in fact, this is not real.
you're introducing a whole lot of additional potential points of failure on top of that.
Exactly. Yeah, you need to maintain a Kafka. What happens when the Kafka producer comes went down? Who is going to restart? What
Yeah.
happens Kafka consumers when there are many complicated cases that we have encountered,
Yeah.
and you're not getting anything out of this, right? You're not increasing. In fact, this is much slower. then using what we do in OpenMetadata, which is instead of Kafka producer and everything else, we have a connector and we have an intelligent connector. So it is your day one. You're talking to Snowflake. We scan all of your data, right? Your queries, your logs, everything else to bring it in into OpenMetadata
Hmm.
and use it in a efficient way that by our performance standards and our scalability measures, any other open source, we are 10x faster than available open source platforms that
Hmm.
we can test against, obviously, right?
Yeah.
What we do here, so we are getting all of your data. Once you get it, we take a watermark of that, saying that, hey, this is a good copy now. From here onwards, any changes doesn't require a full scan of the system. It requires incremental poll, which is today, let's say we took at 10 a.m. PST, the full scan. The next one, when we do at 11 a.m., we don't go ask Snowflake to give all of your data, all of your metadata. In fact, we only say that, hey, let's look at what changed from 10 a.m. to 11 a.m. PST and only get that.
You're just getting the deltas between the scans.
Exactly.
That's going to greatly reduce the amount. So you got the initial scan, which is going to take maybe a little longer. Obviously, there's more data, but once you've got that, like how often is anybody realistically spastically changing their schemas? It
Exactly.
seems like it's just simply not that voluminous of data, like with an Uber and you've got trips and everything else going on where things are firing
Yeah.
off constantly.
In a company like Uber, changing your schema is a catastrophic event.
Yeah.
You need to make a conscious decision with your downstream consumers who are reading your tables, who are reading the tables 10 steps down the line. That's the beauty of open metadata. That's what it does. It brings in all the lineage in front and tells you that, hey, if you're making this change, there are 10 people who will be running around on December 31st, in your name that you've made a broken, you lacked a broken change. So
Yeah.
schema changes doesn't happen that often, right? It's crazy to think that, oh, we need it. A schema change on a whim. The important thing to watch out for is how do you bring your consumers into play rather than how do you put Kafka and make it a lot more complicated to get notified of the metadata change. There is an argument saying that, hey, I want to make whenever my team creates a table across the organization, like anyone creating the table, I want to register into open metadata as soon as possible, like immediately, right?
Mm.
Because I need governance. There is certain standards that we set for data contracts. There is certain metadata specification that we set up. All of those are enabled in open metadata, and anyone creating should get into open metadata not 30 minutes later, not 10 minutes later. Either of these architectures, just because you put in the Kafka doesn't make it like, oh, I'm going to immediately land it into a metadata store just by adding the Kafka.
Yeah.
Remember, you still need to pull from a Kafka producer, push into Kafka, your consumer needs to read and put into one. And here is where the beauty of OpenMeta comes into play. It is built on metadata APIs and SDKs. The
Mm.
world, the world of internet runs on APIs and SDKs. You don't think twice when Uber, if you open, again, taking the example of Uber, it can't get more real time than ordering a taxi and someone actually telling you that the taxi's ride is accepted. The driver is coming to you in the real time
Yeah.
where their location and your location, right?
Yeah.
So all of that is enabled through APIs.
Yeah.
So
Yeah.
APIs are the foundational pieces of that. That's what we have built on metadata APIs and SDKs. It's very well thought out. It's very well documented APIs and SDKs. Now, in the world of going back to our use case, I want metadata to be real time. Use our APIs and SDKs, publish it. That's what we do. For example, in Airflow, we can get a notification when the pipeline is getting run, how long it ran, what actually is changing in the tables. We get a real-time notification as the tag is running, as your workflow is running. Same thing with your create tables and everything else, right? So if someone is creating a table, there has to be CI/CD mechanism. You can embed a automated client and publish it.
Yeah.
And there is no real time than APIs and SDKs. I want our audience to understand just by publishing to Kafka, you're just adding another hub and another complex architecture component that you have to maintain, someone has to maintain instead of using an APIs and SDKs. And all of these APIs always gives you a clear, ideal error code, right? If
Yeah.
OpenMeta is down, you get an error code. You can retry. OpenMetadata can be built in a fashion that you can run multiple servers so that you can load balance, you can have periodic failures, the other server can take over and take the request.
Well, in the Kafka case, so if you've got a Kafka producer and it actually is making use of the API and the SDKs that are available from the vendors, you're doing it anyway. Like throwing the
Exactly.
whole Kafka pipeline and the consumer and everything, it's such a ridiculously heavy, like it's a sledgehammer to put a tack in the wall. It just overloaded. And Kafka's got its entire infrastructure as well. When you say Kafka,
Yeah.
it's not like this one program that's sitting there running. There's an entire infrastructure around that. So and the vendors have a vested interest in their APIs and SDKs being solid, tested, fast, and everything else.
And another argument that we can, I'm playing the devil's advocate here, right? The case where the teams can say that, hey, I don't want to my engineering teams, my business teams, my data governance teams to learn about open metadata APIs and SDKs. So one part of that argument is why is that, right? APIs change, SDKs change. That's again going back to open metadata philosophy. We build based on specifications and standards. You can go to
Mhm.
openmetadastandards.org and learn about how the specifications are aligned. All those specifications not only embedded into client, as well as servers, as well as UI, as well as ingestion components. So when we say a table should look like this, the format of metadata, it is
Mhm.
consistent across our ecosystem. You get validation
Right.
errors right in the client. So it's as simple as like learning any other API that you can. It's really well written and easy to adopt. Having said that, now dissecting that argument further, yes, that's great, Harsha, but I we already have a lot of knowledge in the Kafka. And we have clients embedded everywhere. I know we build some gateways, it makes it easy. Great.
Mhm.
Now, that's where the power of OpenMetadata comes into play. If you have to have Kafka, it is really, really easy because, again, we build OpenMetadata based on standards and schemas. These schemas are JSON schemas. And Kafka, if you're using Confluent Schema Registry or any schema registry that is available, they support JSON schema, Avro protocol out of the box. So your marshalling
Okay.
and unmarshalling of your payloads becomes that schemas in OpenMetadata. So your team,
Mhm.
if you want to use Kafka, we are not saying no to that.
Mhm.
I would, if I have to do it from day one, again, I would go with what OpenMetadata offers today.
Yeah.
Combination of using the connectors. In the cases of where I have to push metadata immediately, I will use metadata APIs and SDKs. Makes it easy, makes my life rather simple.
Yeah.
But there are companies who are already ingrained in Kafka and they build a lot of things around Kafka. They can't move away. And that's a standard architecture team setup. Great. You have metadata schemas in JSON schema. Use that, publish it. We have a Kafka consumer that can read from Kafka and publish into open metadata. So nothing changed.
Nice.
We can do both ways, but I want to kind of, we are doing a Mythbusters episode today. I think just putting Kafka doesn't make you real time. It adds more complexity for a
Yeah.
small scale,
Mhm.
right? Roughly, I'm saying. So it's not much data that needs to flow around.
Yeah. Yeah. I mean, it's
So you
small.
don't need, yeah, it's really, really small. You can actually, publish it really, really fast. So that's one
Yeah.
of the reasons we have done that 2 million data assets testing without including any Kafka in between live publish of the events into our open metadata
Mhm.
and 1,000 concurrent users. It's not like I have 1,000 users, they will come once in a day or twice in a day. No, 1,000 concurrent users. This could be your process who are probably reading from open metadata. These are real people who are doing governance, searching, discovery, updating tables, and everything else. We were under 400 milliseconds for all of those requests. That's an extreme scale, right? You can
Yeah.
scale up from onwards from there, and we'll keep consistently around even further lower down. Um, so again, the simplicity is where you can actually there is a beauty in simplicity. So that's
Yeah.
one of the reasons we have said, hey, we're gonna build as simple as possible that can scale for small organizations all the way to the enterprise organizations.
Yeah.
That's a goal of open metadata, and we've been really successful with scaling it. We have many open source users using it at extreme scales. We have in open source using medium to small scale,
Mhm.
and it works. It fits for every organization.
So basically, you can do this however you want. We got the fastest way to do it. If you've got Kafka, need to use Kafka, you can have that in your pipe, but it certainly isn't providing a real time metadata infrastructure. There's too many stops in the road,
Yeah,
that's going to be introducing latency. And yeah, if you think you're putting it in because you're getting real time, you're
yeah.
You're misinformed, shall we say.
Exactly. I mean, there is definitely a use case, right? So
Yeah.
this suffices because OpenMetadata provides you so many things, right? The
Yeah.
other side of the equation of OpenMetadata, which is I want to, when the K table lands, when the answer table lands, I want to publish in OpenMetadata, great, but I also want to notify all the downstream consumers of this change. That's
Mm.
what OpenMetadata excels at. It takes in that change and tells the downstream consumers that, hey, Harsha is changing order underscore ID to order ID. You're on the users who are using the order underscore ID as your column in one of your reports, tables, dashboards, or whatnot. Please be aware of this change that's coming your way.
Yeah.
Right.
Yeah.
So,
It was great to spend some time on just this aspect of it and really illustrate, you know, what happens in that context. It's very easy. You see people running around going, "Oh, we're using Kafka, so now it's real time." There's a lot of details in there, maybe not so much.
yeah.
I've seen this before when people are talking real time.
Yeah, and the use case matters too, right?
Yeah.
A user ordering a trip requires a real time changes. A metadata change event also requires, but again, the automation there, the use case there of that is Uber needs to enable probably 100 different services out of that particular real-time thing on downstream. When
Yeah.
it's metadata change event, if you're putting the open metadata first, it will notify all the other changes. You don't need to worry about having yet another Kafka component there.
Well, thank you so much, Harsha. I appreciate you taking the time to go through that with me, and I'm sure everybody will enjoy watching it.
Thanks, Shawn.